Hello, welcome to this video. In this video, let us derive mean effective pressure for an Otto cycle. Remember, mean effective pressure is a hypothetical pressure which is thought to be acting on the piston throughout the cycle. I mean to say, uh, we have this equation of work transfer. Now, work transfer is given by P into dV, right? So, work transfer is given by P dV. Now, if you look at this cycle, this pressure is not constant, it is varying throughout the cycle. Now, imagine if I replace this pressure by some mean pressure, I mean let us go for some horizontal line. If it gives me the same amount of work transfer as this cycle is giving me, then I call that as mean effective pressure. So, mean effective pressure is a pressure which is thought to be acting or which is constant throughout the cycle. It is not just because it is varying throughout the cycle. Which pressure shall we take here? So, we know the swept volume, but if I have some constant pressure which can give me the same amount of work this cycle would give me, and I call that pressure as mean effective pressure. So, this has to be actually mean effective pressure where P suffix m, which we are calling it as mean effective pressure. Now, let us derive this equation for mean effective pressure. Now, what is this mean effective pressure? I will just rearrange this term. P mean must be equal to W divided by swept volume, that is dV. Now, dV is nothing but V1 minus V2 here. You see, swept volume is from here to here, right? I mean, swept volume is from here to here. This is our clearance volume. So, let us name it. So, this is our swept volume and this is our clearance volume. Okay. So, this is our swept volume. This is our swept volume from here to here. From here to here it is swept volume. This is our clearance volume from here to here. Now, swept volume can be written as V1 minus V2. Now, V1 is total from this cylinder head to here. This is our V1, all right. Now, V2 is nothing but clearance volume. So, from here to here is V2. So, therefore, Vs can be I mean swept volume can be written as, now dV is swept volume can be also written as V1 minus V2. Okay. Now, let us call this as expression 1. Now, we will come back to this expression later. Now, call this as expression 1. Now, work divided by V1 minus V2. Now, this work is actually work net, not just W. This is actually work net, all right, work net. Now, how do we get this work net? Let us write work net. Now, I will simplify. Let us take only numerator, simplify W net first, and then we will come back to this expression 1. Now, W net can be written as, now there is two works actually here. Either we have used in terms of heat transfer in the efficiency expression, but however, this can be written as there is expansion work from 3 to 4 and there is compression work from 1 to 2. Now, expansion work minus compression work we can write. So, that will be work 3 to 4 minus work that is supplied, that is 1 to 2, all right. See, the moment I use negative sign already, I should not substitute this W1 to 2 negative, that we must take care of, all right. Now, W3 to 4 is PV power gamma is equal to constant reversible adiabatic process. So, for reversible adiabatic process, we know PV, that is P3V3 minus P4V4 by gamma minus 1 minus, already I am using negative sign here. So, it is my duty to substitute this in positive. So, it is now P2 V2 minus P1 V1. So, this has to be taken care because already have used negative sign divided by gamma minus 1. So, this I am keeping it in positive, keep in positive, very important because already I have used negative sign. Now, I can take this 1 by gamma minus 1 common, 1 by gamma minus 1 common. So, I will be having this P3 V3 minus P4 V4 minus P2 V2 minus P1. Now, what we can do is that I will take P4 V4 common in the first term. So, P4 V4 common in the first term. So, I will have P3 V3 by P4 V4 minus 1. Similarly, in the second term, I will take P1 V1 common. I will have P2 V2 by P1 V1 minus 1. So, this will be our expression, and we can further simplify this in terms of compression ratio. Now, remember compression ratio is what? Compression ratio here is V1 by V2. Okay, V1, that is V1 is total Vc plus Vs and V2 is Vc. And we also know that V1 is equal to V4. We also know that V1 is equal to V4 and V2 is equal to V3. So, whenever we get this ratio also, we must be able to write that in terms of compression ratio, all right. So, now V3 by V4 is 1 by R then. See, V3 by V4 is 1 by R because R is V4 by V3. So, now this expression goes on like P4 V4, this P3 by P4 I will write it as it is, and this will be 1 by R minus 1. Similarly, here in this expression P2 by P1 and this will be V2 by V1. So, V1 by V2 is R. Now, V2 by V1 is 1 by R minus. Okay. Now, we also know this expression that like we know that, or we can derive from here that pressure and volume ratio we can write, right. So, P1 V1 power gamma is equal to P2 V2 power gamma. So, if you want P2 by P1 ratio here, so P2 by P1 ratio here, it will be V1 by V2 power gamma, which is nothing but R power gamma. So, I can write P2 by P1 as R power gamma. Similarly, I can use P3 V3 power gamma is equal to P4 V4 power gamma. So, I want P3 by P4 ratio here. So, P3 by P4 is equal to V4 P4 P3 by P4 is equal to V4 by V3 power gamma. Now, what is V4 and V3? It is same R. So, P3 by P4 can also be written as R power gamma. So, I will replace this now. Now, I will right now we are deriving for work net. Remember, we are talking about work net. So, 1 by gamma minus 1 P4 V4. Now, this term I am writing it as R power gamma. Now, this is R is there only 1 by R minus 1 minus P1 V1. This can also be written as R power gamma divided by R minus 1. Okay. Now, this can be further rewritten as 1 by gamma minus 1 P4 V4. Now, this if it goes to the numerator, it will be minus 1. Now, if you add those power R power gamma minus 1 minus 1 minus P1 V1 again. Okay. Now, this is again R power gamma minus 1 minus 1. Okay. Now, I can take this R power gamma minus 1 common out here, and this 1 by gamma minus 1 is here only. Okay. Now, in the we have now P4 V4 minus P1 V1. This is what we have. Okay. Now, I can take P1 V1 common here. If I take P1 V1 common here, let us check what will be remaining with. we'll have P4 V4 divided by P1 V1 minus 1. I have taken P1 V1 common. Now V4 and V1 are same. See, V4 and V1 are same. Okay. So V4 and V1 are same. So therefore, they will be cancelled out, and I am denoting now say P4 by P1 is pressure ratio RP. Okay. So pressure ratio. Then I can rewrite this P1 V1 R power gamma minus 1 divided by gamma minus 1 into RP minus 1. So this is our expression for work net. Okay. So this is our expression for work net. Now we will go back to our equation 1 where we were. Now let us go back to equation. Let us call it as equation 2. Now what we have done is we have got an expression for work net in terms of compression ratio and pressure ratio. Now substitute this in equation 1. Substitute in equation 1. Now mean effective pressure, if you recall the expression, mean effective pressure is work net. So P1 V1 R power gamma minus 1 divided by gamma minus 1 into RP minus 1. Now this was work net divided by our swept volume V1 minus V2. So this was our expression. Now let us simplify it. How do we simplify this? So V1 I can take out common here so that I can cancel numerator and denominator. So from this expression in the denominator I will take V1 common so that I can cancel out this V1 in the numerator. RP minus 1. Now if you take this gamma minus 1 is there only, I will take V1 common here. So it will be 1 minus V2 by V1, V2 by V1. So now I have cancelled out V1 and V1. Now that will be, we have remained with P1 R power gamma minus 1 RP minus 1 divided by this gamma minus 1. Now this is what? 1 minus 1 by R, because V2 by V1 is 1 by R. Now we'll just simplify it further. P1 R power gamma minus 1 RP minus 1, where that is pressure ratio, divided by gamma minus 1. Now this can be written as R minus 1 divided by R. R, this will go to the top numerator. So P1 R power gamma minus 1 RP minus 1 and divided by gamma minus 1 R minus 1. So that is an expression for mean effective pressure in an Otto cycle. Okay. So let us take few problems on Otto cycle in the next video. Thank you.